Now, in this series on pipeline field joints, we are focusing on coatings and linings. And in our previous discussion with Neil Webb, we took a look at some of the unique challenges that are associated with coating these field joints. Most notably, of course, from its very name, we are working under less than pristine conditions because we are really in the field. And today we're going to zoom in on a very common group of field joint coatings, which are known as the hot applied coatings. And I'm absolutely delighted to welcome a very special guest today, Juan-Paul Locke. And he's really in the field, just like those pipe joints, because he's dialing in from site. So welcome, Juan-Paul. Thank you so much for coming today. Juan-Paul has been working in the pipeline industry for many years now, largely in the quality. So with the challenges in the field and the concept of good quality coating, that really is his daily lived experience. Right, Juan-Paul, as we get going today, we're going to be talking about hot applied coatings for field joints. What coatings would that include that you've got experience with?
That's usually a sort of coating system that requires some sort of a heat source or energy source for the application, such as a shrink sleeve system that you can get, or the polymer modified bitumen membrane system that is also quite popular within our field, and also the most common use option available.
And I would guess that polymer modified bitumen membranes, or often abbreviated as PMB membranes, being quite common, you've had a lot of experience with them. Why would you choose those specifically? Whereabouts would you apply them?
Most typically, we've used them on larger water pipelines that already comes with a factory-coated bitumen coating. But yeah, mostly on any diameter pipeline, you can use them if it's compatible with the factory coating which pipes comes with.
And the bitumen coatings are a very obvious choice. Now, yesterday in the session with Neil Webb, we spent some time talking about surface preparation. And we spoke about the fact that some coatings require significantly more arduous surface preparation than others. When we're talking about the PMB membranes, what kinds of surface preparation are required, firstly? And secondly, how do you actually achieve that on site?
So the most commonly way that we clean the joints after the welding team has released them for the coating team is by using a small angle grinder with a wire wheel brush. That will enable us to remove any dust, mill scale, any other contaminants that may be left behind on the surface, to be able for us to polish up the surface, get it nice and clean. Usually the standard is SA2.5 that we use for external joints, which is our Bible that we work according to ensure that we have a properly clean surface, to ensure that we get good bondage between the bitumen system and the steel surface.
Then if you're going to be using an angle grinder, then I presume you also have to have some sort of power supply on site.
Absolutely, yes. So that would usually be either a small generator, or if the welding teams are close by, we can usually just plug into their welding machines and piggyback off of them.
That makes quite a lot of sense, to feed off each other and work together. One of the things that we mentioned yesterday as well was that there can be a delay in production because of your field joint process. Just your comment about working if the welders are close by. What is the time delay between them finishing welding and when you can start applying the membrane? Is there a long delay, or can you usually get right in there and proceed with the coating?
Pipeline, it's a construction site. You can plan as much as you want to, you can execute as good as you want to, but there will always be something adding a delay. So especially with the testing that needs to be conducted with the welding before you can actually release it for coating. So that might be a day or two, which is probably fine and acceptable. But the moment you start cleaning your joint, preparing your joint for the coating, that's when it's getting crucial. That's when the window for the application actually decreases, because you don't want to clean your surface, leave it nice and clean, and leave it open for possibilities of any contaminants, especially dust. Dust is one of our bigger problems with this. So your window, usually, I think most manufacturers would recommend that there's a 4-hour window after preparation to when you should have applied. Otherwise, just pre-prepare the area and clean again.
Okay. So I'd forgotten about the fact that after the weld, there's testing that happens, and that does add a delay. But you're absolutely right. We want to get the coating on after the cleaning as quickly as possible. Now, Jean-Paul, we're talking about hot applied coatings, and I know from our brief discussion earlier that it's baking hot on site, but I don't think it's quite hot enough for the coatings. So how do you get the necessary heat energy for your PMB membrane?
That's usually by use of LPG gas storage, just to apply some heat. We don't need to burn the material. You just need to apply enough to have the surface area melt slightly to ensure that it gives off like a sticky, now I'm lost for words. So on the membrane itself, you need to just melt slightly on the surface area, and that will enable you to actually coat properly onto the steel pipe. That will cause adhesion and ensure that it doesn't come off. You can try your best. Once that bitumen is on, it will not come off if done properly.
Well, that's always the key thing, is that we want excellent adhesion of our field joint coatings. So it's good to hear that if it's applied well and you've got that molten bead of material, that you will get good adhesion, and ripping it off is what we want to avoid. So it's good to hear that we can prevent that by heating adequately. I was wondering about, you said earlier that we could apply PMB membranes to virtually any pipe, but when you've got very big pipes or very small pipes, I'm not sure in what dimensions this membrane is supplied. So how practical is it to have different pipe sizes, and what changes between, say, a 1.2 meter diameter pipe and, say, a 700 pipe?
No, it's definitely practical, especially if you have a completed pipeline project, which is a few kilometers. Your suppliers usually will cut the tape according to the size of the width that you need and also the length. So then I'm sure they'll be able to accommodate almost any size for you. I've done pipes 2.1 diameter all the way down to 450 with bitumen as well. And the tape is being cut exactly to the spec you need. Smaller pipes, it is a bit of a challenge in the trench to get them wrapped because your space is limited, where with the bigger pipes, it's much, much easier, honestly.
That's interesting to hear you say that, because I would have envisaged that a big pipe was actually more challenging. But I guess a bigger pipe, you've actually got a bigger trench, so you do have a bit more elbow room, as it were. Now, for those very big pipes, we're moving this blanket, kind of wrapping the pipe in it. Practically, does that mean some of your applicators are standing on the pipe?
Yes, so especially like I mentioned, like a 2.1 diameter pipe, you will have at least 4 people in a team working on per joint. 2 of them will be on step ladders on the side or at the bottom working with each other, because at least 2 guys need to be working together at all times. One keeping the material in place, the other one heating slightly, and then actually a third person will come and smooth out the joint for you and apply it. So it is a team effort, and that's why I say on a bigger pipeline, it's much easier because of the space that you do have. Where on a smaller diameter, you are limited. So one person needs to hold the material and smoothen it down and apply it while the other one heats it for you.
You don't think about the size of the team required to make sure that the application of your field joint coating happens appropriately. One tends to forget the people component. Let me not say one. I forgot the people component of the exercise. And that's really what we're wanting to convey in this series, is some of the real practical challenges, and people and space are those. Now, one of the other challenges, and you alluded to it earlier, is the effect of the environment, dust, sun, I guess rain. What is your experience and your consideration about using a canopy over the field joint while you are putting on the coating?
With this specific coating and any other coating that you'll get, whether it's fusion bond epoxy or your tape wrap system, the manufacturer will always give you requirements for the environmental conditions as to in which you can apply this. And that should always be kept to, because that's when you have the best application for that material. Once it's done properly. When you are actually preparing your surface and applying your primer where you need it, and there's a lot of dust in the area, all the dust will go and sit on that surface. You won't be able to apply anything. The same with rain. So just stick with the manufacturer's recommendations when it comes to environmental conditions.
Sure. And have you had any experience with using a canopy like a gazebo over the pipe joint? Do you find that's a practical solution, at least from a rain point of view?
When it comes to the actual raining aspect, We have never applied any product when it rains because of the contamination that it proposes. But with tape wrap systems, for instance, it's easier to use a canopy to keep the dust and so forth out. But with the bitumen or any hard applied coating, you don't want to have an enclosed area on top of you for safety reasons when using LPG gas.
Ah, see, you need the practical on-site comments and experience. That's definitely what I need. Thank you. I hadn't thought about that. Absolutely. Now, when we talk about our field joints, one of the concerns with them is after the application, coating's on, and now we go to backfilling. Perhaps a little bit of a sideball question, but are there any constraints related to the backfilling associated with a joint that has got PMB on it?
Yes, okay. So with all honesty, bitumen base is a bit more forgiving than any other type of coating because of its thickness and durability. But the most common issue that we have been facing, and this has been through since I started with pipelines up until recently, is that sometimes you get small rocks, stones, anything like that in the soil that you're using for backfilling. And it might not sound like much, but that causes small pinholes in your coating. And that's definitely a weak point within your coating system there. So if you do use your backfill material, it should always be approved by the client, and there shouldn't be any large stones, rocks, or anything like that that can hurt your pipeline, whether it's on the pipeline itself or the fuel joint.
It does seem quite strange, doesn't it, that we have to kind of almost baby the pipelines like this. But you're absolutely right. Those little stones can cause big damage, and big damage is expensive damage. Yeah, definitely something that needs to be taken into account. And I'm sure sieving the backfill material, that kind of thing, also is sort of fairly common practice.
Yes, definitely.
Right. And so far in our discussion today, we've really focused on PMB membranes, which from all you're saying, they sound quite easy to use, although using an acetylene or an LPG torch on site has me thinking of Star Wars arguments with children, but maybe that doesn't happen with adults. There are other hot applied systems. Heat shrink sleeves spring to mind. Do you have much experience with those?
No, first-hand experience. I've never worked with any heat shrinks, but I have obviously come across it in the years that I've been in pipelines. I've read about it. I've seen videos about it, and even though the end product of a heat shrink sleeve is extremely nice, I've found that honestly, it's a system that only experienced people can use. And for pipeline projects such as where I'm working on, it's not don't want to say acceptable. It's not feasible because of the time that you're actually using on per joint as to the PMB membranes, because you have to use a lot of time, a lot of heat, ensuring that the entire shrink sleeve covers your entire joint, not leaving anything open, no air bubbles, nothing like that.
Yes, and I think we must always take into consideration that generally our workforce is often not as skilled perhaps as we would like them to be. And so, as you say, the PMB membranes are quite forgiving and easier probably therefore to train people on. And to the best of my knowledge, many pipeline contractors today are using their own teams as opposed to an external field joint specialist company. So I think there's also those challenges of training up people in different roles on a project.
Yes, no, definitely. So with our projects, we're in the remote locations where we are working everywhere. It's part of our core understanding and our core values to employ the local people and to train them up, to get them up and get them certified for various things on a project. So one of those aspects where we always get local people and train them up is with our external coating team. So definitely the PMB membranes is much easier to apply than any other hot applied system.
And that's been really interesting information. Now, casting my mind back, I remember when I was working on the NMPP pipelines for Transnet, they also used hot applied systems, but completely different from the PMB membranes. They were using a fusion bonded epoxy system with a very fancy heat applied tape. And if I recall, they had this, I almost want to call it a train, set up with the first part of it would do the blasting, and the second part of it would do the FBE, which obviously has specific heating requirements. The pipe then had to be contained. And once the pipe was heated and the fusion bonded epoxy had fused, then it was coated. And it was quite an extensive I imagine, quite expensive operation, but it was many hundreds of kilometers in pipe. So that was quite practical, and really isn't practical on a short line, or, as you say, a line where we can upskill local labor, and where for example, the PMB membrane is an appropriate application for the pipeline mainline coating. So yes, just talking about, we mustn't forget that there are other hot applied systems where the PMB membrane is a very practical solution, but as you rightly say, very forgiving and very easy to apply within our South African context. And some of the other hot applied systems do require more extensive training for the application process, or are sufficiently complex that you need a very long pipeline in order to be able to use it effectively. And I guess the size of the pipeline, or the length of the pipeline, I should say, can also determine the complexity of the system that is employed for the field joints.
Yes, and in all honesty, we are actually blessed in South Africa with the amount of different products that you can use. For instance, where you have a system like that, which was practical for the project, on a smaller project, definitely not practical. The cost is too high. So there's a lot of products out there, whether it's a fusion bonded epoxies, hot applied systems, tape wrap, that we can use for smaller projects, which makes it much easier for smaller companies to apply. It's easier for people to train on them. So we are honestly blessed with a huge range of different products that we have access to for these pipelines, whether it's small pipelines, small diameter pipelines, all the way to bigger pipelines.
Indeed. And it's encouraging to see that we also have the breadth of pipeline sizes used in different ways across the country. And I know this digresses from specifically talking about field joints, but there are smaller lines going in municipalities, and then the bigger lines for water and fuel and gas going in the more urban and peri-urban spaces, sort of providing the bulk mains, as it were, for our pipeline systems. And that does give us some variety in the various products that can be chosen. And that's one of the joys of what we're trying to achieve from this series, is that we will be exploring some of the other coating systems to which Juan-Paul has alluded. And as we start wrapping up today, just to say that we will be continuing discussions next week on looking at cold applied tapes, for example, which are also widely used, very commonly used, and relatively forgiving. And we'll discuss those in some detail. And we'll also be looking next week at liquid applied coatings for the external. So those are some of the options to which we can discuss further next week. Now, I've just received an interesting question come in, and the question is, would you need to specify a sand-based bed or layer for a PMB membrane, or is it not that susceptible to damage? And the question says, would you need to specify a sand bed, especially for a heavy pipe? She's just wanting to preempt concerns with the specification, and also obviously costing and scheduling.
Any material, once you have excavated your trench, any material going into that trench should be specified for which purpose, whether it's your bedding layer, your selective backfill, or just a common backfill, because each of those has a purpose. For instance, with the heavier pipes, you don't want any large pieces in your swell stones or anything like that. You want it soft, but still firm enough to be able to handle the weight of the pipe and not cause the pipe to sag, which might cause issues on the welding itself. So definitely, all your materials should always be discussed, tested, and approved by the client before being used. So that's one of the key components actually with our pipelines.
Thank you. And also just as an additional comment to say that the softer the coating, the more one needs to have protective padding or bedding at the bottom of the trench to make sure that we don't get any spurious damage onto the coating. And there's another question that's come in about storage, which is something we've not discussed. Are there specific storage requirements for PMB membrane on site? Is there a maximum period of time that you can store the material before it should be used? What constraints are there in terms of storage?
Yes, no, definitely. So the manufacturer will, on the data sheets, will always specify the shelf life that the item has. Now, the shelf life is when the material is actually being properly stored. For instance, on sites, we have specific containers just for this type of material. It might be a bit hot in there, but it doesn't get too hot. There's no other environmental issues coming in contact with it, whereas opposed to just leaving it out in the sun. If you leave that type of material in the sun, it's not going to last long. It would have lost all its mechanical properties and it won't work as designed. So definitely you need to take care of where you store your material, because the better you store your material, the longer it will last, the better material you'll be able to apply to have that final joint.
Thank you, Jean-Paul. That was very interesting and helpful. And I hope that we've adequately answered the questions that were sent in. I really wanted to thank you for taking time, literally off-site, for joining us as our guest today. It's been so interesting to hear about some of the challenges and the usefulness of hot applied coatings from someone who really does use them, kind of sharing your hands-on perspective. So thank you.
Thank you for having me. I really enjoyed this, and I'm looking forward to the next episodes that you guys will be having.